I will present our project, the e-commercial product recommendation. Here are our three members. And let's first look at and take an overview of our project. It consists of two parts. The first one is to do the user-based recommendation on Spark, and here is an example of user-based recommendation. The user A and user C both bought product 2, so they have a high similarity. And then we found that user C also bought item 3, so we recommend item 3 to user A. And the next part is to do the recommendation on system G. It uses item-to-item similarity. First, with the breadth first search, we found all nodes with breadth 2 to node 1. And then among all the nodes, we found the one with high similarity, which is the node 2. So we recommend node 2 to node 1. Now in this graph, we can see the input and output of our two parts, and then we combine the two outputs to be the input of part 3 and realize the chain recommendation. Our total data set is about 1.14 gigabytes. We download the data set from this website, and we can see the metadata format. It concludes the item ID and customer ID and rating. So we wrote a Python script to grab these three important information and construct a tuple in form of and from this is user ID and item ID and rating. Now let's see the second data set. It's used for Spark for system G, and it's in form of node pairs. Each node stands for an item ID, and edges show the relationship between the nodes. So here is the data set of Spark for system G. Now I will show you how to execute our program on Spark. Because it takes some time to do all the to execute all the code, so we have already have some results here. I can show you. Yes, the first thing is to here. Here, the first thing is to import some package, some Python package. For example, ALS is alternating least square. It's used to compute the similarity of collaborative filtering on Spark. And then we load our data set into the variable data, and then split the data and define some important parameters, including rank and number of iterations. Then we train our model. And we compute the MSE to evaluate our training model. We can see the MSE is about 1. It's not very big. And now we can find it's our code here, and we can use this phrase. Sorry. And so we can use this phrase to know the top 10 recommendation of on Spark, and it's the result. It means for user, this one we recommend the item, and with the rating, which is very near to 5. And we list the result here, and you can have a clear view of the result of Spark. And
for our second part, we will do recommendation based on item level on System G. For example, we will choose one of our results from the first part, the item, source item, with ID of this, and we will do item to item recommendation and choose the top 10 items to recommend to this source item. And we will do in a way to calculate the number of paths connected from source item to target item on a specific depth, and recommend the top 10 with the largest numbers of paths in the descending way. You can see from the result of our example, most of these items are still in the same category with the source item. On System G, the code we used mainly is collaborative filtering. It will have the input of a graph, and it will come out the result of the numbers of paths from our source to each vertex in the graph, and ranks these vertices based on the number in the descending order. So we will choose. So in this way, we choose the top 10 vertices to do the recommendation. And that you can choose different depths, which will have different neighboring graphs. Here we choose the depth 4. By combining the first part and the second part, we will get our third part, recommendation chain. For example, for one user, we will recommend some items based on user-based recommendation, and in the first part, and then for each item we get from the first part, we will recommend 10 more items to each items based on item-based recommendation on System G. Here is the outcomes of Part 2 model. This is the left graph is the whole picture of our input. Each node actually represents one item. We will choose our example item and see it's a labeling graph on different depths. we only choose the depth 1, 2, and 4. And in our example, we recommend the top 10 items in the depth 4 from these 245 items. I will show you how to do it on System G. First, we will for the input of System G, we will only choose the load and the edges and put them into CSV file. Here is the edges. The left one is the source, the right one is the sink. And actually, I built a graph named Amazon. Zero 302. After inputting our files, we will get a graph of the whole picture like this, and the edges is actually the length between the source item and sink item. And then we can use System G to find the item with the max degree. And also use this code to check the labeling graph of specific node with different depth. And by using this code, collaborative filtering, we will choose the top 10 items for each source item, and the result will be put in the TXT files like here. From the result, we can see for one source, we will recommend the top 10 items, and according in a descending way of the number of the path between them. This is the source. This is the recommended items, and this is the number of paths we are used to recommend it for our source item. Actually, you can compare different recommendation on. You can compare the recommendation on different depths, and choose the one with the best result. I think that's all about our project.